Hi, everybody, and welcome to a lecture on single static class diagrams, which is part of the Unified Modeling Language, like version 101. We're just covering the basics here. And what we're going to learn here is how to visually represent. We're going to visually represent a class using the Unified Modeling Language, which is a visual language that allows us to communicate software requirements to one another. So here's the problem. You can write classes in a whole bunch of different languages. Over here on the left, we have Python, and over here on the right, we have C#. And these are essentially the same class. If we take a look at them, we can see that they both are named car. They both have initializers, which take a year and model. Here's the car with year and model on the C# side. We initialize the data attributes to those values being passed in. And not only that, but we have these underscore ones here. So that's like our private. That's the things that people shouldn't be able to touch. And then we get the speed, and we've got a get speed right here, and we've got accelerate, and here we've got accelerate, and it adds 5 to speed, which it does here. And then we break, and that breaks there, and we reduce by 5 on the left hand. So these two things here, these are essentially the same class, just written in two different languages. And so any object-oriented programming language should be able to, say, I need a way to be able to say, I want to build a class. And that way we don't have to worry about the specifics of Python or C#. We can just have pretty drawings that describe our classes and the relationships between those classes. So with the unified, and again, we say it's unified because it doesn't matter what language it is. And the modeling part is we're going to take a class definition like this right here on this side, and we're going to make it into a visual representation with some structure to it. And the language itself is a visual language, which is something that we don't often think about. We think of languages as words and letters, but visual languages also exist like this. I mean, emojis themselves are a visual language. So we start off this idea of a class right here. So we have a class, and all classes are a box. It's a rectangle with 3 sections: the class name, the attributes, and the methods. So we're going to take a step-by-step thing here in filling out what this box should look like given this class definition here. As you saw, the top here, the first box is the class name. So we take the name of the class, car, and we plop it right here inside of the top. And that's it. The first thing is the car. Class name, done. Up next, we take the data attributes or the fields or whatever you want to call them, the private members, the public, the data members, the instance members, the instance variables, the instance fields. All of those things are the same word, really. So our data attributes, that's what a lot of people call them in Python. Our data attributes are put here into the second block, right here, the second block. So you can see we have, and we're not looking at the things on the right-hand side here. What we're looking at is the things on the left-hand side. These attributes on self, which are being created inside our initializer and perhaps in other methods as well. So you can see we have underscore year, that gets listed in here. We have underscore model, and that gets listed. And we have underscore speed, and that's what gets listed. Now in Python, we don't say anything about type information. We don't say that year has to be an integer or model has to be a string. But in our UML, we like to give as much information as possible. And so for any data attribute that we've got, underscore year, underscore model, or underscore speed, we put a colon and then the data type that we expect to be after it. And that gives us more information when we're making this class here that will know that underscore speed, because it's an integer, we should be able to do math with it. And for underscore year, because it's an integer, we have to format it a specific way. And maybe model here, because it's a string, we can uppercase it. And so these data attributes end up being in the first place here. They end up being in this first block, and then their name, type. That's how it is. If you don't care about types, because some Python programmers are like, types don't matter in Python, that's fine. You can actually just list the names without the types like this. And then people just sort of like have to figure it out based on more information in the problem domain or something like that. But I'm a big fan of types. I think it gives us some extra information that's really nice. And so because of that, I try to put types on here all the time. So integer, string, integer. And so our data attributes, again, go in the second section. Up next in the UML, we have what are called visibility modifiers. And visibility modifiers mean who can actually interact with things outside of the class. And so that's the important part. So if I do something like car is equal to car, and I give it the year 1972, and I give it like town car, like that. It's a Lincoln town car. So when I'm outside, when I have an object, when I'm outside of the definition of the class, when I'm using this object, whenever I do car dot something, this right here, this thing, whatever I would put on the next to it, that has to be public for me to be able to use. It's public. It's like a public entrance. Everybody can use it. But then we also have things that are private, which means that we don't want anybody to use them here outside of the class. So here I've got self underscore underscore year and underscore underscore model and underscore underscore speed. In Python, whenever I have the name of something like a data attribute or a method that begins with at least one underscore, it's considered to be private. And that means I should not access it out here. I should not ever do something like car dot underscore underscore year. I should not do that because it's private. It's private. It's only for inside the class here. It's only so that we can use it inside the class. We should never use it outside of the class after a dot somewhere in our code. The only dot we should ever use this stuff is after self dot inside the class. And so generally, data attributes are considered to be private. We want them to be private. And because they're private, we put this minus sign in front of them. The minus sign means these are private and should only be used inside the methods of the class itself. Like underscore underscore speed is private and it's only used inside the class. We would never do something like car dot underscore underscore speed. Underscore underscore in Python does some like fancy name mingling, so it becomes impossible to do this. But you'll see code where somebody has a class with like car dot underscore dot underscore speed, and it's only one underscore. That's still considered to be private. It's not private because it absolutely is, and you can't get to it. It is because of convention. So when you want your data attributes or anything else to be private, the way that you do it is you give it at least one underscore at the beginning of the name, and then in your UML, you'll put minuses there. And so all of our data attributes are private and should only be accessed from within the class. In that last block here, we put our methods and our ctors or initializers, our initters. That's also another word, initters. Ctors means constructors. That's what they're called in other languages. So methods and constructors and initters, basically any kind of method, they go in the bottom down here. And so we have 4 methods in this class. We have our initializer right here, and so that ends up going there. We have our getSpeed function or method, which goes right here. And we can see that this returns self.speed, and we know speed is an integer because of this right here. And so getSpeed is the name with the parentheses because it has no parameters, and I'll talk about that in just a moment. Then colon, and then the return value of integer. Then we have accelerate here, which is mapped to this. And in this case, there is no return statement. So we don't put anything here. There's nothing here after it. And then we have the break right here, which is right there. And it also doesn't return a thing. So some people like to do colon none to say that it returns none, that it returns nothing. So some people write it like this. Some people write it where there's nothing after it. Okay. So now let's take a look at these parameters here. You can see here on each of these things, there is a self parameter being provided by Python automatically. These are called auto parameters because the language is making them for us. We don't do anything. We don't pass in a value for self. Self just comes from Python all by itself. We pass in a value for year and model, but we don't pass in a value for self. And because we're not passing in values here for any of these selves, most UML practitioners will not put the self over here inside this. Okay, so we basically ignore self in these method signatures over here when we put them into the bottom of our UML diagram. We just know, because we are excellent Python programmers, that if I were to get this really cool car class like this, I would know that get speed, when I write that, it needs to be def get speed self. I know that self has to be there because it's an instance method for my object of the car class, even though there's no self there. Previously, when I was talking about minus means public, now minus means private, plus means public. And I want people to use all of my methods here. I want them to create a car and get the speed and accelerate the car and brake the car. I want them to do that. And so plus means public. And so I put plus on these so that everybody knows it's totally okay for them to, create a car instance and then do car.brake. That's totally fine because that's how I designed this. I want them to be able to do it because this is what's known as the public interface. Public interface. And the problem with the word interface is it's used a lot in programming, and so it has like 17 different meanings. But in this case, what this means is this is the stuff that I'm allowed to interface with, that I'm allowed to use. It's the public portion of this class. So I can call car.brake. I can do car.getSpeed or car.accelerate because I want them to be public. And so other programmers can look at my UML diagram here and know all of these things here are public, so I can totally use each and every one of those. And that's it. In general, in Python, we just put the class name here. We list all of our data attributes and their types. If you like types, I like types. And then we generally make them all, private. We just make them private. And then we list our initializer and all of our methods here, and we generally make all of them public. And you'll notice here that for the parameters, we do name, type. Name, and that should be a colon, sorry about that, type. And so name, type. That's how we specify name, type. That's how we specify like parameters and things. And here we have a function, type. Okay, so the types always come at the end in UML. So this is what our finished static class diagram for the car class looks like. So one more thing here, we want to talk about inheritance relationships. So this is another part of the visual language. When I see a class that has an arrow with an open triangle pointing at another class, I know that this class here is inheriting. It inherits from. And that's really important because the arrow tells us which direction. So in this case, gamer inherits from person, which means gamer is a person. This is a specialized kind of person, whereas person is just like the generic or general person object. So this is the base class, and this is the child class, or the subclass, or the specialized class. Remember, there's a whole bunch of different words for this. And up here, this could also be called the parent class, okay? So gamer inherits from person. The arrow points from the subclass to the base class, and it has an open arrow like that. So if you go and you look if you do like Google search or an image search online, and you're like, I want to search for UML images, you'll see like one class inheriting from another class like this. So it doesn't always go up. I just want to be really clear about that. Sometimes it goes sideways. Sometimes it goes down because that's just the way that it looks. But this class here, this would be the subclass, and then these would be the two parent classes, parent and parent over here. So you have to watch which directions the arrows are pointing to know which is the subclass, which is the parent class, because it's not always going to be subclass on the bottom, parent class, base class on the top. That's it. UML is a visual representation language for classes that have three sections. The top section is for that class name. The middle section is for its attributes. The bottom section is for its methods. Then minus means private, which means people outside of the class, code outside of the class should not touch it. Plus means public, which means these are the things outside of the class when you're using an object you should be able to use. And then the open triangle arrow shows the subclass to base class relationship, and that's this arrow right here pointing up. Gamer is a person, a specific kind of person.